from one hand to the other fellow's hand without movement. Okay, so if there are 30 persons, 30 meters stone will be passing and it will be reaching from the source to the destination. That is something like an example for conduction. If you ask a practical example, if you touch a handle of a pan which is on the stove, you will feel hot. And when you are feeling cold, God forbid, let it not be COVID-19, you are going to a doctor, I am suffering from hyperthermia. That is fever. What is fever? When you are suffering from, when your heat, that is temperature is above 98.4 degree Fahrenheit, doctor touches your forehead and he feels that it is hot. How does he feel? The heat energy from your body, since you are above 98.4 degree touching your forehead, he is at 98.4 degree Fahrenheit. You are at elevated temperature, 103 degree Fahrenheit. He is at 98.4 degree. When his finger touches your forehead, he feels the heat and he senses, yes, you are suffering from fever, hyperthermia. So keep cold water, keep something like a cold cloth and so on. And then he jabs the injection, paracetamol and so on and so forth. Okay. So something that like that is practical example for conduction. Okay, you are in a room and the room wall is west faced. Around 2 o'clock in Ramagundam, you will be reaching 55 degrees centigrade. If you touch the wall will have a blister on your hand. Isn't it? That process is conduction. So there should be physical contact and there should not be any movement between molecules that transfer energy. Then that mode is called as conduction mode. And one more example, all the electronic devices generally have heat transfer through conduction mode in a computer or in any electric lamp and so on. And there is one more day-to-day example is you are removing the wrinkles in your shirt or pants or something like that using iron box. Iron box transfers the heat energy by contact and therefore it is an example for conduction process. Now comes the second mode called as convection. And Professor, is my speed okay? Okay, I will continue the same speed. Convection. When energy is transferred from one molecule to another molecule, where molecules move from one place to other place. Here, the movement is substantial. In conduction, there is nil movement or very least movement, whereas here, the molecules move in a substantial way. Perhaps it moves even in kilometers distance. Okay.
Okay, sorry for the interruption for our audience. Please we stay on the line. Sorry for the inconvenience. Please be stay on the line. Technical issue is there. Please be stay on the line. Thank you for your patience. Please be stay on the line. ఏందమ్మా
Professor, am I audible now? Hello.
Yes, sir. Yes, sir. It is audible, sir. It is
Okay,
audible.
my screen visible?
Yes, sir. It is visible. Thank
Okay.
you, sir.
Suddenly power went up and
No,
somehow
no
it
problem, sir. No
is
problem.
good. I'm sorry to have been interrupted and sorry for making you wait. Okay, now let us resume convection. Energy, when energy is transferred in a mode when molecules move in an appreciable manner, for even it moves, as I told, even kilometers distance from Earth surface, water is evaporating and it is moving to sky and it is getting called as cloud. So all those places, all those processes and phenomena are called as convection. So convection is the mode of energy transfer when molecules move. Example, as I told, oxygen, atmosphere, and in ocean, heat is received by surface water and it becomes what do you call it, heavy. Heat is given by surface water, it becomes heavy, it goes down, and again the water in the surface is heated, and something like that. It is going on rotating. The water is going on from up top to bottom and bottom to top. All this happen because of something called as convection current, which is due to convection mode of heat transfer. Okay, and convection is the predominant process that is happening in almost all the heat exchangers that we use. And the same brick example, we can tell people are now standing with gap in between them, say 5 feet or 10 feet. One fellow is taking the brick, one fellow is picking up the brick, he is moving and giving, and that fellow is taking to somebody else and he is giving. So here it is movement. So you can remember the brick passed physically by a person from one place to another place and handing over is called as the example, or something like simile for analogy for convection mode. Okay, and now comes the third mode of heat transfer, that is radiation. When you transfer the energy, there is no molecules in between two bodies that are getting heat exchanged. And when there is no molecule, you cannot transfer using conduction or convection. And still energy is transferred using something called as electromagnetic waves or some waves, and that mode is called as radiation mode. Okay, the example, our brick example is, I am taking a brick and I am throwing with more power and it is landing somewhere around 500 meters. Okay, that is called in between, nobody is transferring it. I am just throwing. When how I am throwing, I am giving some energy. In the same way, sun is transferring energy, heat energy to earth. In between sun and earth, there are no molecules. But sun is converting the energy, heat energy into electromagnetic waves or similar waves. And that waves transferred from sun to earth and we receive precious energy through some mode called as radiation. Okay. And whether we know or not, whether we think, what you call, wish or not, any body which is above 0 Kelvin are transferring heat transfer through radiation, whether we are having atmosphere or not. Okay. There are so many laws and acts and theorems and so on and so forth. And you, in cold countries or even during our winter, we will be sitting in a room and in a corner there will be something called as a firebox. Okay, in that firebox there will be heat chunks, fire chunks or something will be burning. We will be around 5 meters away from it. We will be receiving the heat predominantly due to radiation. Okay, so these are some of the examples, practical examples for radiation. Okay, and now comes the wonderful invention that combines all the three modes of heat transfer, which is called as thermoplasm. This fellow, Sir James Dewar, is the scientist who has invented the thermoplasm. We all know thermoplasm's purpose is it retains the temperature of the contents irrespective of the surrounding temperature, isn't it? So when I pour hot coffee, the coffee will be hot, irrespective of the outside temperature is either chill or hot. If I pour cold wine, it will be something like ice. Yes, so that is called as thermoplasm. And now, whatever material, whatever body, whatever object that carries cold items are named after this gentleman. The flask is called as Diva. Oxygen Diva or helium Diva or the something like flask or bulbs. This fellow is having a bulb. No? This is also now called as Diva. It is called as, they are predominantly used for carrying cryogenic materials. Cryogenic means study of sub-zero temperature. Not only sub-zero, it is roughly around minus 270, minus 260 Kelvin, that temperature. Or it will tell, I mean, minus 270 degrees Celsius, I stand corrected. In absolute temperature, 4 Kelvin to 11 Kelvin is helium's liquid. So we'll touch all those things in the slides to come. Now, please know that it's the thermos flask that prevents all the, that reduces or prevents all the three modes of heat transfer so as to retain the temperature of the contents inside. Okay. How does it does? How does it do? Okay. We all know, perhaps if you have opened a thermos flask and dropped it, you've been knowing almost all the 90 kids would have received so much beatings from their parents after breaking the thermos flask. Okay. Inside the thermos flask, there is a glass bottle, will be having two walls, okay, separated by vacuum, and you can see it is reflecting. The surface is perfectly reflecting. Here you can see a nipple. While making some glass, liquid glass, they will be sucking all the air in this gap between two walls. Okay, you know, air is a conductor of heat. So it is an insulator of heat, still it conducts. Whereas now, if I suck off all the air, and inside there will be vacuum. After that, I will be sealing it. That's why you will see the glass is what you call crushed, like made like a cone. Now, inside the flask, there are two. Only on the top it will be open. In the bottom, first less area, the two things will be touching. In between two walls, there will be vacuum. Now, coming back to all the three modes, I am pouring hot water inside. Outside temperature is, say, 15 degrees Celsius. Hot water temperature is 60 degrees Celsius. Now, it has to conduct. There are three modes. Conduction mode is prevented. How conduction mode is prevented? There are two walls, but both the walls are not touching other than the top. Top, it is only small area touching. Okay. So, since the walls are separated, you are preventing conduction. Okay. And now, convection. Since there is vacuum, there is no fluid inside. You know, only fluids carry predominantly convective mode of heat transfer. There is no air, there is no fluid, liquid or fluid, it is vacuum, therefore convective mode is prevented. Of course, there is the all pervasive, what mode? Radiative mode. Now, I have told you, inside also there will be a coating, silver bromide or something like that, and outside also it will be polished to something like mirror polish. If you see here, here also the fellows some what do you call gadgets are seen. The flask will be reflecting your face, so it is something like a mirror. So whatever heat is coming from inside, it will be reflected inside, and whatever heat is impinging from outside, it will be reflected. You can see here. Here there is no reflective coating. Heat is entering and exiting using radiation. Whereas here you can see, in the right side, you can see radiation is prevented. Therefore, radiation mode of heat transfer is also switched off by providing a reflective lining inside and outside. Now, all the three modes are not happening. Therefore, heat, hot fluid is retaining its hotness, whereas cold thing cannot seep inside. And that is the purpose of thermos flask, invented by Sir, this fellow, James Dewar. Okay. So now comes, why should we study heat transfer at all? क्या फायदा है मुझे? Okay. Here I will tell a simple thing. When an American see a car, he will say how big it is. Okay. He wants, Americans, you know, wants everything bigger. And for four people traveling also, that fellow will be having a Hummer, which is like a tank, that much size. When an Italian see, he will see for cows, oh, how glamorous it is, how beautiful it is, something like that. But when an Indian see a car, he will immediately ask, "Kitna deta hai?" What is its consumption? Okay. So we want always a faida, use. So why should we study heat transfer? It's always a degree stopping subject. people used to complain. It will be having already partial differential equation of second rank, second order, and always we fear our mathematics master for mathematics. We'll be having maths one area, we'll be completing it in final year. So again, this below heat transfer is coming, which is having so many derivations, integrations, whatnot, initial condition, boundary condition, blah blah blah. So why should we study heat transfer at all? Okay. So heat is energy, and so long as we are having energy, we are powerful. Powerful means we should have power. What is power? The capacity to do work. And what is work? Energy. What is heat? Energy. So if you have to be called as powerful, you should have energy, and you should know how to transfer, receive energy. And that is the simple purpose we have to study energy. And during the process, either we want to enhance the transfer rate or retard the transfer rate. These two words play the role during our study of heat transfer. I repeat, when we want to have the heat transfer process, in some places we enhance the transit, and in some place we retard the heat transfer. Okay, that is the purpose of, simply stated, that is the purpose of study of heat transfer. Okay, we will see examples. Where all we have our heat transfer rate enhanced. In an IC engine, we want to have immediately all the heat transferred to the, what you call, see, one third of energy is converted into work, one third of energy is carried by what you call flue gas, and one third of heat has to be immediately transferred to the cooling medium. So if it is slowly cooled, imagine IC engine will get seized. Okay. So there we want to enhance. We want to increase the rate of heat transfer. And next coming our thermal boilers. Okay. Here also whatever heat is possessed by flue gas, we want to remove all the heat from the flue gas before the flue gas gets out of the boiler or gets out of the chimney. That's why you are having so many exchangers, and at the top of the chimney, you will be having air preheater. So as far as possible, as fast as possible, we want to enhance, we want to receive all the heat from the flue gas. So here also we want to enhance the heat transfer rate. In furnaces, we want to again receive heat transfer very fastly. In heat treatment process, suppose you are quenching, okay, you are cooling the hot metal. Suddenly you want to cool means you will be having oil bath, not water bath, because water is what you call, it will get evaporated, and the oil, what is that, evaporation temperature is more than that of water, so you will suddenly immerse it. There if the heat transfer rate is slow, instead of martensite being formed, you will have always lead-brite or bainite, that is metallurgy. Okay, so here also you want heat transfer rate to be faster, right? But now tell me, there are some places where you want the heat transfer rates to be retarded, slowed, so, or prevented. In AC room, you are sitting in an AC room which is having around 25 degrees Celsius temperature. If the heat is from outside, imagine again Ramagundam. If the heat from outside is quickly transferred to inside room, your AC will quickly get into damaged situation. So there you want to prevent. Again, we have seen oxygen dewar. Oxygen or helium or liquid nitrogen are transported in liquid condition. If outside heat is quickly entering in the dewar, then what will happen? Liquid oxygen or liquid helium will evaporate, and when evaporates, it is constant volume material, bar or jar. What will happen when evaporates? When constant volume, the pressure will increase and sudden bursting will be taking place. Imagine some 1 week or 2 weeks before in Bombay, it, oxygen leak took place, and instead of saving the people, it killed around 18 people, if I'm right. Unfortunate situation. Okay, so in all refrigerated places, you want heat transfer rate to be retarded or slowed. Okay, these are very few examples for the places where you will enhance the heat transfer rate or you will retard the heat transfer rate. Right? Now let us start from conduction. Some example. During winter condition, again the same Ramagundam will be registering 5 degree or 10 degrees Celsius. In North India, it will be touching 0 degree also. You will be covering your body with a bed sheet. Okay, you are going to think for a while, and the bed sheet is of 6 mm, very thick, 6 centimeter thick. Its conduction coefficient is say 0.5 meter Kelvin. Okay, only one thick bed sheet. Will this be more effective, or I am having two slices of same material bed sheet but only 1 mm thick, and this one again 1 mm thick, but in between I am having air gap which is having 1 centimeter thick. Okay, this is 1 centimeter, same material, and the air conduction coefficient is 0.02 watts per meter Kelvin. And again bottom I am having, so something it is like I am having a layered bed sheet. Think and tell which will be more effective during winter. That is, the outside coldness should not come inside to me because I am a warm-blooded animal. My heat should be preserved. If my heat is going out, next day you will be placing Professor Velu, is late Professor Velu in ice box. Okay. So which will be preventing heat? Now think and tell. Perhaps you should be wondering, it will be a thick bed sheet. Okay. Now going for an elementary calculation, let us see. If you are having a thick bed sheet, the heat transfer rate is around 1/12 of watt. Okay. It's not meter Kelvin, it's 1/12 of watt. Whereas in this case, it is 1 by 52 of watt. Imagine it is around 4 times slow heat transfer. You know, and that is the power of inserting air inside the bed sheet. Okay, something like you can have two dhotis, and in between you can embed with beads like our grandmas did, and if you just cover it, you can withstand any bloody wind. Okay, so this is happening due to conduction. Since air is an insulating material, even though it is having a kind of conduction, it prevents conductive heat transfer when it is embedded. And this is the principle in cold countries, you know, in what you call Arctic Pradesh. It's not Andhra Pradesh, Arctic Pradeshams. You will be having igloos where the Eskimos live. Igloos. Igloos are made up of ice cubes. But inside ice cube, you know, it will be semi-spherical dome-like structure. Inside it, you will be having so warm air. How? You know, if you just burn a candle, all the candle heat will be taken by air, and the air will be going to the top of the what you call igloo, and it will behave a perfect insulator. So outside temperature, even if it is minus 30 or minus 40 degrees Celsius, the coldness cannot creep in. That is that is how Eskimos can live in a very cold region. And you people would have seen in European countries, or the buildings built up by Europeans in India will be having very tall buildings, and the ceiling will be at least twice tall like our home. In our home we will be having the ceiling around 11 feet. Okay, whereas in a hall it will be around 20 feet. Why? Again the same thing. If you have a high ceiling, during winter you will be feeling warm because your air will be going, it will become hot, it will go to the top near the ceiling, and it will prevent the outside temperature coming down. So you will feel cool. And during winter you will feel warm because of this particular air getting trapped inside the ceiling. Air acts like a perfect insulator, and conduction is prevented. Okay, and that is one or two examples. And of course, yes, all the handles of your cooking utensils you make using plastic. Otherwise you need a separate cloth or something like tongs to hold it. When you are making a handle using plastic, you can handle, your mother would be doing in dosa tawa, kadai, all those things will be made up of metal, but the handle will be made up of plastic or something like a hard wood which will not be transferring heat. That is conductive heat transfer related. Now coming to convective heat transfer, and mostly we will deal with the convective heat transfer as I told you, the process that are happening day to day, which are of more importance to we engineers is the convective heat transfer. So that's why we will be dealing more examples. Okay. So we all know, your professor would have told, heat transfer Q is equal to heat transfer coefficient multiplied by area multiplied by the difference in temperature, HA delta T. Okay. Here, which is under your control? If you want to increase or decrease Q, which is under your control? Certainly not this. Delta T is not under your control, whereas area is under your control, and to certain extent, thermal coefficient, convective heat transfer coefficient is also under your control. We will see by increasing the speed, we can convert from natural convective heat transfer to forced convective heat transfer. We will see how those things in the coming slides. Okay, so convective heat transfer is governed by something like Newton's law of cooling, which your professor would have told. It is the simple equation that we are going to exploit so as to enhance the convective heat transfer or retard the convective heat transfer. Okay, we'll start from biology. You know, engineers always wonder about biology, and they have invented so many things by getting what do you call mimicked by biology. Biomimicked advancements they call biomimicked algorithms, and so on and so forth. Okay, so we learn from Mother Earth. So here you can see an African elephant, which is having a very large broad ears. And here you can see Asian elephant, common quite, but small ear. You know what's the purpose of ears for elephants? And yes, you would have guessed it right. And they serve as the radiator of their body. They cool blood temperature, and blood is giving the heat, and the outside air is taking the heat. And this broad area is doing the magic. Why then African elephant is having broad ear rather than Asian elephant? In Africa, it is desert, you people know, and it is so hot, notoriously hot. So they have bigger radiator, and here Asian elephant, not that much hot places, they are having smaller radiator. Okay. Again, when you see an elephant, it will be always moving the ears. Why is it moving the ears? Again, it wants to have forced convection rather than natural convection. I'm damn certain you would be knowing what is natural convection and what is forced convection. If the convection current is not accelerated by a fan, then it is natural convection. If you are having a fan or a driving propeller, impeller or pump or similar body, then it is called as forced convection. This fellow, though it's having a meter square of air, still that fellow will be keeping on moving. That means when you are, it is something like you are fanning yourself. So the heat transfer rate will be high, and this fellow will be cool, and he will be steady. And that is the function of ears, and that is how heat transfer through convective mode is linked to biology. Okay, let us see one more example. The day-to-day fellow, which you would have seen. This fellow is protruding his tongue out. Why? Again, this fellow has radiator here. Okay, it's again same purpose. Otherwise, no need for this fellow always to protrude the most precious thing in his body, the tongue. Okay, here it is. Let us come to our example. You know, when I am coming to your home, you would be offering me a coffee in a cup. Okay, and it is steam hot. Generally, coffee will be taken steam hot. And if I take and have a sip, then my entire lips and tongue will be burnt. So what do? You are offering me a saucer also. Okay. So a cup and a saucer. Generally, they used to tell a cup and saucer. Why do we need a saucer? So we are drinking a fluid, or drinking a liquid from a cup. Why do we need? If you pour hot coffee on the saucer, within no time, the coffee temperature is drinkable, isn't it? How does it happen? Here it is less area, here it is more area. And remember this equation, if you increase the area, heat transfer rate is increased. Like our big elephant, African elephant, big ear. The same thing you are doing, you are increasing the area. So if I am pouring liquid coffee, hot coffee, it is having more area to get convected, and immediately it becomes to a temperature which is drinkable. Right, gentlemen? Okay. Now, I am weak in mathematics. Perhaps you can tell me The diameter of the cup is 5 centimeter. The diameter of the saucer is 10 centimeter. Okay, the diameter is increased by 2 times. Now, how many times the area would be increased? Okay, you can see, you remember your 10th standard formula, 9th standard formula. You will be knowing the area increased by 4 times, and that is why we are having a saucer, which helps us to enhance the heat transfer rate from the hot coffee to a drinkable hot coffee. Understand? And that is why we people take our hot food or porridge or kanji or something like that in a plate, a bigger plate. Whereas we take some cold items in bottles. Okay. Now, also, we have seen convection. Convection means heat is transferred from one body's molecule to a liquid or fluid body's molecule, and the fluid body, if it receives heat, the density decreases, it becomes lighter, it goes top. Lighter bodies go top, and heavier bodies come bottom. Again, the heavier body receives heat, becomes light, goes top. The hot body goes up and gives the heat, becomes heavy, comes down. So it is like a current, it is like a circuit, it's going on and off. Okay, so how that particular thing is daily useful for us also. As we have told, though we are warm blooded animal, above 98.4 degree Fahrenheit means we think it is very dangerous, it is fever, so we have to get rid of the heat. But it is not what you call always we can keep temperature under our control. If you do exercises, very hard exercises, or if you work physical work, strenuous work, what happens? And you are in Madras, where immediately Bangalakapam is there, Bay of Bengal is there, and next to each and every street, Kuam will be going, which will be having water. Bangalakapam is having more water. So, water will be there in air, and the air cannot take your body's heat because already it is. So, what do we do? God has made something called as sweat. And why do you sweat? What happens after sweating? Imagine if you drop one drop of petrol on the back of your hand, you feel immediately chill, isn't it? So what happens? Exactly, heat transfer. The liquid petrol is always volatile, and if liquid petrol has to become vapor petrol, it has to take heat. From where it will take heat? From your body. Since your body is giving heat and petrol is taking heat, petrol is evaporating and your body is feeling cool there. That is why when some aerosol or petrol is dropped on your hand, on your skin, you feel chill. Exactly the same thing is happening in your sweating, my dear engineers. Okay, when you sweat, the sweat bead is coming out. And the sweat is made up of water molecules also, in addition to salt molecules. And why salt is there, that itself is a wonderful engineering created by God. Okay, the water molecules evaporate. And from where it will take heat? From your body only. So when heat is going from your body, the temperature in your body is maintained at 98.4 degrees centigrade and you are feeling comfortable. Understand? That is the purpose you are sweating. And now imagine why sweat should be salty. Why cannot it be normal water? Okay. Imagine you are not only in Madras. Okay. Sometimes you may be in Europe or Canada. And in Canada during winter time, what will happen? Temperature will go below 0 degrees centigrade. But you will be strenuously working or jogging. Okay, your body will become hot. Now sweat is coming. If it is not having salt in it, it is something like a refrigerant. Water freezes at 0 degrees Celsius. And already the outside temperature of Canada is minus 30 degrees Celsius. Before something like sweat, which is made up of water in imaginary situation, before it comes out, what will happen? It will expand and the veins in your body will be cracked. It will be torn. Then we will have our natural this thing. So that should not be taking place. By mixing salt in water, you will reduce its freezing temperature. That is called as brine solution. Okay, brine solution means, what is brine solution? the temperature, freezing temperature will be far less than 0 degree centigrade, because if you circulate brine solution, you will get even ice. How? When ice is formed, when the temperature is reduced to below 0 degree, when the temperature of water is reduced below 0 degree, you will get ice. So if you circulate cold water also, you cannot get ice. Therefore, brain solution makes it. And you are having a brain solution in your body itself, and that comes out, which is called as sweat. Understand? And when it evaporates, the body temperature maintains the body temperature. There is a thermostat. You know thermostat, the instrument used to what do you call measure temperature and inform it. So the thermostat in conjunction with sweating neutralizes always your temperature to 98.4 degree Fahrenheit or 36 degrees centigrade. Okay. So the top two things have been seen. How does water poured in what you call mud pot during summer days will be say 4 or 5 degree less. We are not those our forefathers were so intelligent, but they were not going for freon unfriendly refrigerator. They were having wonderful sustainable item called as mud pot. How does it? Yes, in mud pot you will be having nano size pores or micro size pores through which water will be oozing out. Slowly it will be oozing out. It is not leaking. It's very slow amount of water coming out. And when that water evaporates, water and air always are friends, having a very great affinity. Okay, not only human beings want to uh, um, drink water, air also wants to drink water. I am not meaning the other water, it is only H2O. Okay, so air, when it sees that too in dry time, air will be thirsty. Air also will be thirsty. Something like, uh, you know, समुंदर ने आवाज दीजिए मुझे मुझे आम आवाज दे मुझे पानी पिला दीजिए. So air is thirsty, and slowly water is oozing out from the mud pot. The air takes that water, and when water has to mix with the air, it has to be steam. So from where, if water has to be steam, it has to gain energy. From where it will take? From the water which is inside the pot. So inside water is the pot, water is cooled, and outside it is getting evaporated, and so on. And this is the precise what do you call method by which you are having the air coolers that is functionable in hot and dry places like Hyderabad, Nagpur, Bhopal, etc. In Madras, that will not be feasible because already here it is hot, however, it is wet. Wet means the humidity, relative humidity will be around 90% or so. Whereas in Hyderabad, you don't have any rivers or lakes or of that sort. Already water is shortage there. So there your relative humidity will be around 40 or 50%. So if you mix water with air, the temperature of air will come down and you will feel little bit cool. Okay. So poor man's air conditioner is water cooler, and that functions exactly using the evaporative water cooling method. Okay. And of course, finally, people used to carry desert bag. Mud pot is heavy, so they are having desert bag made up of something like canvas. It is also functioning in the same way. Otherwise, if you open water, half bottled water will be evaporated immediately. So, and you cannot also drink in, say, scorching 55 degrees Celsius in Jaipur. If you drink water at 55 degree, the water will itself kill us. Okay. So that is the purpose of heat transfer, and that is how we are using evaporative cooling technique. That evaporative cooling, again, it is convective heat transfer mode. We are enhancing the temperature, I mean the heat transfer rate. Okay. Now all along we have seen we don't have a fan next to our pot. We don't have a fan next to our gunny bag. Desert bag. It is taking naturally. God is circulating, but it is slow. Now we are, see, I am talking in my from my room, non-stop talking. You people would have now seen going on talking. The problem is in online. I don't know whether you are having doubt, or whether you are sleeping, or whether you are with me. But however, I am vividly talking, dancing, and doing gestures, something like in front of me. You are there. I am having a fan just rotating above my head, say 3 or 4 feet. Why should I need a fan? So when I am speaking to you, my metabolism rate is there and it is giving heat, it is generating heat. I am a hot body. So if heat is not drained, it will be, I will be suffering hypothermia above my operating temperature. That is not good for me. Okay. So again my body starts sweating, like from the previous slide whatever I had told. And if I am leaving it to the care of God, God is not blowing air, so it will be sultry and I will be feeling irritated. So what I do, if you are keeping a fan, you would have seen in some advertisement also, somebody will be irritated and somebody will be providing air conditioner or air and they will be becoming calm and quiet. So if I am having fan, what I am doing, I am blowing the air and the air is now taking my sweat fastly and my heat transfer rate is enhanced. Understand? Instead of natural convective heat transfer using a fan, I am making it forced convective heat transfer, by which you remember that Newton's law of cooling, that formula, by which area is same. The area of my body skin is 1.7 meter square. Any average body area is 1.7 meter square. And all the 1.7 meter square area, almost everywhere you will be sweating. All those places you will be cooled. Instead of increasing the area, you cannot increase. You are increasing the convection coefficient, which is having inside some room for speed, velocity. So I am increasing velocity by fan, thus I am increasing the heat transfer rate. Strictly speaking, convective heat transfer rate. Again qualifying forced convective heat transfer rate. Why forced? The fluid is under velocity. It is forced. I am using a pump. I am using an agitator. I am using a fan. I am using a propeller to propel the fluid. So heat is carried away by air and the heat is given by my sweat and I am cooled. Heat is taken by exchange. Okay. And now how to increase here, there you have seen you can increase the velocity, but you are creative. Okay, resources might be limited, my dear gentlemen, but creativity is unlimited. By increasing the area, I cannot increase my body area, but whereas my cylinder area can be increased, so that when it is moving, forced air will take the heat transfer, forced air will take the heat, and the heat transfer rate will be enhanced. How to do that? And that exactly is called as fin. Fin is called as extended surface. Okay, if you take a cylinder, what is surface area of your cylinder? Using your elementary knowledge, you can tell pi 2 pi r h, right? Outer surface area. But that is not sufficient to transfer heat. So what do? You are increasing the area by providing something called as extended surface fin. And all those surfaces will now help you to conduct the heat, I mean to convect the heat from inside the cylinder to outside the atmosphere. Okay, so area is increased and therefore heat transfer is increased. Therefore, your cylinder will not get seizure, will not get trouble. That is why you need fins for the cylinder block. Not only for the cylinder block, wherever you are generating heat inside, you should have fins outside so that the system is functioning for quite long time. Otherwise, it is short-lived. Okay, it means it's immature death. Here, an air compressor. See how it is coiled, spiral. Okay, this is low pressure compressor. From here, you compress air and it goes to high pressure and it is going for your use. You have compressed air use at innumerable places in industry, for your trucks and vehicles, inflating the tire, and where it's that's why I told innumerable number of applications. But when you are compressing air, why should you need multiple stages? First question. And why should you need in between something called as this coiled pipes, which is having again something like fins exactly, some surfaces which are protruding, thin aluminium foils that are embedded. Why should you do? Yes, if you want to compress, I'm sorry, near my home, as usual. electric people are digging today. Day before yesterday, corporation people were digging and they, what do you call, close the pit. Today, electrical people are digging. Day after tomorrow, drainage people will be digging. They also want work. That's why you will be hearing that thumping noise. And the compressor is working there. Okay, coming back here. If you want to compress in only one particular cylinder, you need enormous big cylinder. You people would have studied in your thermal power engineering or some chapter where it is big. So you are compressing it in between stages, and when the hot air will be transferred to other place, if you push the hot air within a what you call confined volume, it will be difficult to compress. But when you cool it, what happens when you cool hot air? It is cooled, the temperature comes down. When the temperature comes down, volume comes down. When volume comes down, your pumping work is reduced. Okay, and how to cool it? By using heat exchanger. And this coiled pipe is heat exchanger. You know, direct in some places you would have seen only one pipe directly joining here. But now I want perfectly cooling. So what I'm doing, I am increasing the area. How to increase the area? Coil it. And how to increase the area of the pipe? Provide fins outside. Like this one. You have provided fins like this. So this is called as intercooler that cools the hot air coming from this compressor to this compressor. And your efficiency is increased. How your efficiency of the compressor is increased? By cooling it, by intercooling it. How do you intercool it? Using a heat exchanger. Okay, now you understand what is heat exchanger. Heat exchanger is a object which exchanges heat in between two fluids. Of course, we will see this little later. Okay, so here I have shown you a worm gearbox. You know worm gearbox, worm and worm wheel. If this worm gear rotates one revolution, this moves by only one teeth. Suppose it is having 40 teeth. If this screw rotates 40 revolution, this fellow rotates one revolution only. So speed reduction is very high. It is possible using worm gearbox. Using your normal gearbox, inverted gearbox, or in your automobile gearbox, simple gear train, or even compound gear train, you cannot do. Of course, yes, epicyclic gear train you can do, but it is so complicated. So in the place wherever you want the speed restriction, speed reduction should be very high, 40 or 50 or 100. In one stage, you use worm gearbox. And then when you use worm gearbox, of course, since it is screw moving the wheel, you will be having enormous friction. And enormous friction means enormous heat generation. Enormous heat generation means you should have enormous cooling. And if you are having improper cooling, the entire thing will burn off. So how to do? You will be having oil. You will be circulating the oil using radiator. But need not have that much. You are having fins. Okay. Outside you will be having a fan and you will be having fins. This will be rotating and the fan will be pushing the air through the extended surface called as fins, and automatically the temperature will, heat will be dissipated. Temperature, working temperature of the entire system will come down. It will last long, very long. Okay, like your Duracell battery. Okay, so that is the purpose of heat transfer. And what is the predominant mode happening here? Predominant mode of heat transfer happening here, forced convective heat transfer. Right? This is the second example. And one more thing, that one is mechanical thing, this one is electrical thing. Again, if you see when the motor is functioning inside, you know, eddy current and so on and so forth. I am very weak in engineering. So whenever there is an electric object, automatically it will be also heated. When you are not going to dissipate the heat, it will be fused. You know what is fused? It will become one object. Inside there will be a separate commutator. You will see, you can see so many objects. If it is fused, this commutator will stick on with this outer coil. Then that means gone. 10% is gone. You have to again go on, do the wiring fresh. So what do? You are having a fan at this place. I have shown a fan here, and there is a hood to direct the air which is coming from the fan, and here you are having the pin. Convective, forced convective heat transfer takes place. The motor has a long life. Understand? So imagine each and every component of our life we are dealing with heat transfer. So that's why from today onwards, if you are not willing, if you are not liking heat transfer also, you should have at least a soft corner towards it. Thereafter, heat will become a kind of part and parcel of your body. Already heat is part and parcel of your body. You are a warm-blooded animal working at 19.4 degree Fahrenheit. Still, you will start loving heat transfer. Okay. Next is a very important thing, a gearbox of electrical engineering. What is transformer? It's a gearbox. Okay. What is here gearbox doing in mechanical? The same thing here it is doing. So I tell it as electrical gearbox. What is the purpose of the transformer? To step down or to step up. Of what? Of the voltage. Why have you step up or step down? You know, when you are generating electric current in Srisailam. Srisailam is common for Andhra Pradesh and Telangana. Unfortunately, some days before one accident also took place. All those things happen. So, yeah, when what is the voltage? It will be around 900 volts. Okay, electric current generated from Srisailam thermoelectric, I mean hydroelectric power plant is 900 volts. But it has to be transferred to Hyderabad. Okay, which is around 300 or 400, I don't remember exactly, I have gone through, around 300 kilometers, let us say. If I am transferring at 900 volt to Hyderabad, you know, losses will be very much that when I am creating 1 megawatt of 1 megajoule of energy, you will receive only 10 kilojoule. 90 kilojoule would be, I mean, 990 kilojoule would have gone as losses. Why? You know, power is equal to volt into ampere. Okay. And when you are transferring power with less volt and more current, loss is proportional to I square, isn't it? Power is proportional to I square R. When I is more, loss is squaring, parabolically increasing. So what you should do, you reduce voltage, I mean current, you increase the voltage, losses will be reduced parabolically. That is why you are going to convert 900 volt into 25,000 volt or 33,000 volt in Sri Sailam substation. Therefore, the voltage current will be very less, voltage will be very high. And if you have to transfer current, you need thicker cable. And the thicker cable means more money. And people will cut off and they will take it and they will recirculate it because they are also poor. Okay. Now you can see the wire is not of that much thickness. Okay. So here, therefore, you should increase the voltage. And after you have now received 33,000 voltage in Hyderabad. Your home usage voltage is 230. Already 230 itself is dangerous. You should have only 110. All the developed countries have their voltage as 110 because even if you accidentally touch, you will not be getting electrocuted, God forbid. The 230 voltage is more than enough for electrocuting people. You can see in newspaper at least one fellow will be electrocuted daily. He might be from electric board, either Andhra Pradesh electric board or Telangana electric board or Tamil Nadu, unfortunately. Okay, so now you have to reduce 33,000 voltage to 110 voltage or 230 voltage. Again, what you should do, you will be having a step down transformer. Okay, so transformer steps up the voltage or steps down the voltage. You know how it functions? It functions as per the Newton's law of, Faraday's law of induction. Okay, and when electric current is converted from one voltage and one current to another voltage and another current, there will be heat generation. And if you are not going to remove the heat, what will happen? Again, the entire transformer will be fused as a single object. It will be burnt. Fusing, a wonderful word in thermal science. So you have to do away. So that exactly you are doing. You are having oil, you are having outside fins, cooling tubes, you will be having storage separately, and you will be having pumps inside. Okay. And at times need not pump, automatically hot this thing will be going up and the cold oil will be coming, it will be circulating. Okay. And you will be having a pipe. Have you seen this pipe? Perhaps remember, if you have seen a transformer closely, generally we use transformer for kissing there. Okay. Whenever we see transformer, human beings always wants the hiding behind the transformer. Okay, for lighter sense, don't get angry. Okay, there will be a vent, explosion vent. Why? In case the oil is becoming so hot and it crosses the fire point, you people would have studied flash point, fire point, pour point, all those things in the thermodynamics. So if it reaches the fire point, it will start suddenly bursting. Okay, so it should not happen. Therefore, when there is increase in temperature of this oil, it should not burn, and it should here it will there will be a kind of glass-like thing. The glass will rupture, and the all oil will be just forced out, saving the crores of rupees transformer. Okay, a transformer will generally be 100 crore or something like that, and that is how heat transfer is preventing the burning or fusing of this transformer. Understand? Okay. And now comes all along we have been seeing heat exchanger, heat exchanger. Any body which transfers heat from one fluid to another fluid, the fluid need not be having what you call forced movement, or it can be even having natural movement. That body is called as heat exchanger. Perhaps your professor would have explained about this picture and the temperature curve, hot fluid temperature, cold fluid temperature, all those things. A heat exchanger should have how many things? It should have two fluid. Okay, first thing, it should have two fluids, and it may mix, it may not mix. Okay, one freon in your milk factory, you are cooling milk, refrigerating milk. There, can the freon which is circulating and which is cooling the milk, can you afford it to mix? Can ammonia afford to mix with milk? Gone. There, 100% it should not mix. But in some other examples which we see in later slides, they have to mix so that your heat transfer coefficient will be high. What is heat transfer coefficient? Q is equal to HA delta T. We want to increase that H. Okay, so we are doing, we are finding one system called as heat exchanger, and inside there will be coil of pipes. Why coil of pipes? We have to increase the area, that is why it is coiled. There are so many exchangers you would have seen where you will be increasing the area as well as you will be increasing the velocity of the fluid which is moving through the heat exchanger, by which you will have enhanced heat transfer coefficient. Okay, that is the purpose of heat exchanger. Let us see some examples for heat exchanger which are used in our daily part of life. Okay, always we are fascinated by automobiles. Boy babies will be fascinated by cars, girl babies will be fascinated by Barbie dolls. But engineers are always fascinated by automobiles. In automobile, you would have seen a cumbersome, uh, different type of object which is called as radiator. Though its name is radiator, the predominant mode of transfer is generally convection. So it should have been called as convector, but generally people thought, okay, radiator will be good. Okay, so of course, heat is transferred in any body from any body to any body using all the three modes. For study purpose, you will tell this is the predominant mode, this is the major mode. So in heat exchanger, what is the predominant mode? Convective type of heat exchange, heat transfer. Okay. In hot country, in order to cool the engine, you will be continuously circulating the coolant, and the coolant will be giving heat to what? Our atmospheric air. Okay. In cold country, you will have thermostat and you will prevent. Otherwise, entire heat of our engine will be taken. Say, suppose in Canada you are operating a car, outside temperature is minus 30. If heat exchanger is continuously exchanging heat from the coolant to a cold air, what will happen? Your engine will switch off. But there you will be having a thermostat which will sense the temperature of the, not only there, here also we are having, which will sense the temperature of your engine. And when your engine crosses the temperature of what you call bearable temperature, it will open, the heat exchanger will come into picture, it will cool and it will send the coolant, and so on and so forth. Okay, in the radiator, what are the two fluids? One is atmospheric air, second is coolant or water. Okay, forced convection or natural convection, you are having a fan for moving the atmospheric air. Yes or no? You are having a fan, and you are having a pump to move the fluid or coolant inside the circuit. So is it natural or forced convection? In both the places, both the fluids are moving. So both the exchanger is transacting, exchanging in a forced convection manner. Okay. So the next thing you would have seen here, there you have seen only one heat exchanger. Here you are seeing two heat exchanger. One inside our room called as cooling coil. The other one outside our room called as condenser. Okay. Now you should know what are the two fluids. For when you are analyzing, you should know what are the two fluids that are functioning in the heat exchanger and what is the velocity at which they are going. What is the density in order to pump it or compress it. Okay, how much area is there in the heat exchanger? Is it sufficient or we have to increase the area by adding more fins, extended surfaces, and so on and so forth. So something like this, when you are analyzing, you have to think. If you have to think, you should know what are the applications, and that exactly is the function of this particular session. Understand? Generally, in your theory classes, time will not be permitting your professors to deal with telling these many examples. Okay, and that is why we are in this session. Understand? Okay, inside the cooling, inside the room, I am having split air conditioner. Inside there is a heat exchanger, and what is moving inside? Freon refrigerator R134A or R410A is moving inside the fin, inside the tube, cooling tube. And what is moving outside this cooling tube? The air, atmospheric air, which is cooling me, becomes hot, and it is going there, and it is the cold air which has taken heat from me gives the heat to the refrigerant which is going inside the film. Okay, am I having a fan? Yes, inside the split air conditioner unit there will be a fan, isn't it? It's not something like our table fan. It is cylindrical fan. Okay, barrel fan they used to call it as. So air is forced. And what happens to the refrigerant? Is it naturally moving or is it forced? It is forced. How it is forced? You are having a compressor. Okay, so you are having a compressor. It is moving, and high temperature it is expanding. After expand, it is cold. After hot, after it is compressed, it is going to the condenser coil. In condenser coil, you are having a fan. This fan is moving forcing the air out. The hot refrigerant is cooled, isn't it? Hot air is cooled, and you are having an expansion coil. It is expanded first, and after expansion, it becomes cold. And again, you are circulating in this expansion coil. It becomes doubly cold. So here, it is taking the air from the room. It is becoming hot, and the hot now refrigerant is moving to the compressor, and so on and so forth. It is circulated. Here there are two heat exchangers, one inside, one outside. Outside, what are the fluids? Outside air, and inside refrigerant. Here the temperature is high. Outside temperature is 34. Inside temperature might be say 40. Whereas if you take here, inside temperature of refrigerant will be 10. The temperature of air will be around 20 or 25. Okay, but both are doing the same. Both exchangers are doing the same purpose. What? This exchanger is transferring heat from my air to the refrigerant. This exchanger is transferring the heat from the refrigerant to the atmosphere. Understand? And this is air conditioner in cold, hot countries. If it is cold country, it will be used as heat pump, where heat from the outside temperature air will be pumped to the inside room. Again for cold countries. Okay, that is ulta of this. Okay. Now in a power plant, how to enhance heat transfer? You know, previously people were shoveling coal inside the combustion chamber. We wanted to improve the heat transfer.